Hello students, today you're going to take Cornell notes on temperature. Go ahead and pause the video if it's going too fast, or if you need a minute to set up your notebook in the Cornell style. Make sure you write your advanced questions and have a 4-sentence summary or more than 4 sentences. Alright, let's begin. Today we're going to talk about temperature. Temperature is a measure of the kinetic energy, the average kinetic energy of atoms in an object. Just like usual, I'll give you the first question, and then you have to make up the rest when it's a digital video like this. Traditionally, you might think that temperature is how hot or how cold it is, but actually temperature measures the speed or the motion of atoms. Alright, number 2, and then I'll show you a picture. For number 2, oops, I went too far. If something is cold, the atoms of that object are moving slowly or vibrating slowly, because in a solid they can only vibrate. They can't really flow. If something is hot, as we know it as hot, it's because the atoms are moving fast or quickly, or vibrating quickly. Let's look at a picture. So here in these two pictures, the atoms are moving. Let's say this is a liquid or a gas. Actually, this is gas. The atoms are moving slowly, so this would have the temperature that's lower. And in this picture, the atoms, these little gray circles represent atoms, they're moving around faster. So that means that this gas sample on the right, if it's the same gas, would have a higher temperature. Now remember, in a solid, the atoms can't actually move. They can only vibrate in place. They're stuck, and that's what gives a solid its shape. So they only vibrate in place. If it's a solid, they only vibrate in place. Okay, go ahead and make up your question for 2. Pause the video if it's going too fast, and then catch up, and then let's move on to 3. Are you ready? All right. For number 3, oops, too far again. In science class, usually when you're speaking scientifically, there's 2 scales of temperature we use, the Celsius and the Kelvin. The Kelvin's actually the one that's used more often, but we have thermometers mostly that use Celsius in our classroom in particular. Both are acceptable, but like I said, we don't really use Fahrenheit. Celsius or Kelvin are the 2 preferred ones, with Kelvin being the official, what's called SI unit. All 3 scales, so here's Fahrenheit, Celsius, and Kelvin. All 3 scales tell you, let's say, when water boils, body temperature. Celsius is more useful because, especially when we deal with water, and water is critical to life. 100 is when water boils, and 0 is when it freezes, so it's kind of easy to remember that way. With Kelvin, though, it's very interesting in point 4. It actually measures the actual speed of the atoms, so it's more of a measured speed, which is more of a true measurement of heat or temperature anyways. Alright, go ahead and come up with your question for 3, and then we're moving on to the last point. You ready? Alright, the last idea, connecting to number 3, is that Kelvin scale. So here's the definition. The Kelvin scale measures temperatures as well, but mostly temperatures when it comes to their atomic speed or vibrations. And 0 Kelvin means that the atoms have stopped completely. Although scientists think that might be actually impossible for them to stop completely, it can get pretty close. Let's look at a picture and then you can finish your definition and question. So this picture or graph is a little bit hard to tell, but once you see what it's talking about, it's pretty interesting. Absolute 0 is actually at negative 273.15 degrees Celsius, which is the coldest possible temperature that you can get. Nothing can be colder than that. And you feel like, where does it get that cold? Outer space is a good place. Let's see here. Here we go. Negative 272. So in this nebula, it's actually negative 272, which is almost absolute 0. But humans actually got a little bit closer. So actually the coldest place in the universe has been on Earth, because humans have created something that goes half a billionth of a degree to negative 273. So these are some things that show you how cold it can get, typically here on Earth or in the universe. But the Kelvin scale measures the speed or the motion, and of course 0 would be they completely stop. And again, theoretically, we're not sure if that's even possible. Okay, go ahead and come up with your question for 4 if you have it, and then start your summary and advanced question. Have a good day.